everyone, my name is Phil. Welcome to join our QCen Day 2021. Today, we will talk about the storage capacity and the drive technology that affect the storage performance. What is the future of data center? How do we create capacity and performance for the data-driven world? The key is behind hard drive and SSD technologies. As leading brands in storage and data protection, QCen and Western Digital work together to deliver solutions that push storage forward, and we do our best to assist our customers to reach the future of data. Our era demands more on space and speed for data transfer. When it comes to capacity, we may adapt JBOD to enlarge the space. Also, data transmission speed could be faster with next-generation drive technology. No matter how complex application has become, the core to all of them is data read and write, input and output. We focus on the basic of data, and we believe that is the fundamental to the future of data center. We are glad to have our partner, Western Digital, to join us today. Now, let's welcome Yan from Western Digital.
Thanks, Phil, and now thanks to QCen again for partnering with Western Digital as one of their reliable partners to ride together on this next wave of data explosion era. My name is Yan, and I'm from Western Digital, and I'll be sharing with you all for the next session on some new exciting technology and insight on this topic. Western Digital has been working for years in preparing and enabling our drives to support big data growth. And even by the most conservative estimation out there, we are undoubtedly just at the footstep of an incredible explosion of data. As new standards and resources came out into the market, such as artificial intelligence, machine learning, blockchain, sensors data, smart video, and even Internet of Things are just a few that to be named of. This explosion is growing by the minute. And allow me to take reference from our partner source in IDC. Just in the year 2020 itself, there's already 64.2 zettabyte of data that was created and replicated. And by estimate, we are set to create 2 times more of the amount of data in the next 5 years we have created since the beginning. We can store data digitally. Western Digital has been chasing this rapid growth curve for a very long time, and we are doing this through one of our core strengths at Western Digital, our innovation. Among few of the innovative technology that we have implemented on our drive for the past year to further expand the bit growth, or in other words, the drive capacity, in meeting this data growth is our HelioSeal technology, which hermetically seals the disk drive and replaces the air inside with helium. Energy-assisted magnetic recording and triple-stage actuator for better precision on the read and write operation of the data that can enable cooler and quieter operation, and much more importantly, lower total cost of ownership for even higher capacity drive. These are but just a few of the building blocks of our next innovation. And with the acquisition of SanDisk, which closed in May 2016, provided us with the most critical components for vertical integration. And the last puzzle to putting everything together for this new technology, which is our brand new OptiNAND that will be debuted together with our first 20 terabyte UltraStar Enterprise hard disk drive. Combining both Western Digital hard disk drive and flash innovation, OptiNAND will allow capacity growth on our 20 terabyte UltraStar drive without the need of any additional media or disk or head itself. That means you'll be seeing about 11% capacity growth on the same hardware design, as most of the internal drive metadata will be offloaded from the media disk itself to the iNAND, increasing the total available area on our rotating media for user itself, which is you. Second and thirdly, bye-bye write cache dilemma and hello performance and reliability for all IT system administrator. So why do I say that? So traditionally, as an IT system administrator, you might be troubled with the question is, to enable or not to enable write cache? So for data that is at most importance, a lot of IT administrators would choose to say, okay, I have to disable the write cache feature because I want the data to be written into the disk drive media immediately once it was issued. This is to ensure that the data integrity and data would not be lost in any event of a sudden power loss. However, this comes with a price that you need to sacrifice the performance of the total system itself. In another situation, if by enabling the right cache feature, of course, you'll be seeing much more better performance, as our disk drive can be a little bit much more dynamic on the operation and schedule the read, write, and refresh in the most efficient way possible. Again, this will come back to the scenario just now of a sudden power loss, that there will be still risk that the data would not be written in time to the media if there's a sudden power loss. So this will be a question of the past with OptiNAND, because all of your data, even in write cache enable mode, will all be written into the NAND memory itself, and we are talking about 50 times more than our traditional drive that has no OptiNAND feature. Coming back, storage drives alone can't really meet up the scaling and capacity growth and performance need in what the world needs today, as what I have briefly shared and mentioned. Thus, collaboration and partnership with QCell is a crucial key to success and to satisfy customers' appetite on both of these aspects. So with Western Digital, we're going to focus on continuing enlarging the capacity and performance of our disk drive, while QCell can focus on the scalability, performance on the system level. So with this, I'll be ending my sharing for today, and I'll be passing on to Ethan.
Thank you very much, Yan, for bringing us insight to the latest drive technology from Western Digital. My name is Ethan. I'm the product manager from QCell, and I'll be introducing how these solutions are leveraged to our products. As Yan has mentioned, global data is undergoing exponential growth. In 2020, 64 zettabytes of data was created or replicated worldwide. Here comes the problem. How to store such amount of data? The question becomes critical for delivering data services. So we've got the idea, lifting the density on hard drive. The idea seems simple, but it makes great changes, notably to the budget of enterprise. The reason for that is the consistent operational expenditure. Such amount of spending makes the total cost of ownership lower on large capacity drives for each terabyte of data. The larger, the cheaper. Based on this advantage, we scale up storage step by step. We've learned how Western Digital enlarges the space on hard drives, and QCell works on the scalability of the entire system. QCell storage platform supports hot plug-in and plug-out. Therefore, scaling capacity would simply require physically adding or replacing disks, which minimizes effort on management. In the initial stage of storage deployment, it requires few as only one drive to start. By gradually enlarging storage space, enterprise could resolve the challenges on the way of data growth. Although the capacity is enhanced on a single device, the trend of rising data amount still lays ahead. For artificial intelligence, big data, and edge computing, applications are often based on databases that occupy a large portion of space. That's why we need expansion units to further resolve the challenges of data growth. QCell storage supports as many as 4 Western Digital JBODs on each device, and the expansion units offer 408 extra drive bays. How big is that? Such number of hard drives provides up to 7 petabytes of capacity. The flexible scalability carries out seamless on-demand upgrade. In other words, QCell platforms are capable of fulfilling the requirements at any stage of deployment. We've got single chassis with only a few hard drives, and we can provide an entire server room. Our solutions are capable of accompanying enterprises on the way of expansion. For enterprises, capacity itself may not be enough. QCell works on lifting the availability of IT infrastructure. Our platforms feature active-active dual controller. The architecture guarantees the continuality of services. The failover and failback mechanisms minimize system downtime. Based on the architecture, system maintenance no longer requires reboot. hardware upgrade and firmware upgrade become easier. With high availability storage, agile data services could be implemented. On QCell platforms, we use multiple drive interfaces to optimize system performance. For instance, aside from traditional SATA protocol, SAS is supported on our dual controller NAS, as well as SAN and all-flash array. The third generation of SAS offers a transfer rate at 12 gigabits per second, which goes twice as fast as ordinary SATA drive. In scenarios such as file sharing and backup, it perfectly balances performance and budget. Most importantly, it meets the requirement at terabyte and even petabyte level. Interfaces play an important role in speeding up data transfer. SAS interface has lit up our way to discover the field of all-flash, and NVMe interface is even faster. These protocols allow us to make a further leap on lowering latency. QCell believes that performance isn't privileged to enterprises. That's why we simplified all-flash storage. We break down an entire cabinet to a single device. In the flash era of storage, SMBs and even studios may benefit from advanced IT infrastructure. In the data-driven world, digital assets contribute to productivity. We believe that business of all sizes deserve the best solutions in terms of digital competence. QCell presents to enterprise a native NVMe all-flash storage. It is driven by NVMe interface to achieve phenomenal performance for enterprise-level computing. The benefits of NVMe come along with its microsecond-level latency. In other words, the interface is capable of transferring data millions of times every second. Along with Western digital SSDs, the all-flash array achieves latency at microsecond level. With our software architecture, the speed of SSDs can be leveraged to the entire storage. Our software has undergone performance tuning to optimize the performance of NVMe. We enhanced the input and output of data transfer engine, and we also developed our own thread for writing data. These adjustments enable us to deliver the best performance with NVMe interface. On the various RAID configurations, the storage carries out brilliant performance, and it works equally well on different read and write patterns. All in all, the drive technologies gave us a glimpse on the future of data center. Next, Anthony will bring you more comprehensive view on NVMe drive interface. He will also show you the performance report of our all-flash array and see how QCell and Western Digital jointly deliver high-performance solution for enterprise-level applications.
As SSD gradually replaces traditional hard drives, SAS and SATA protocols are no longer sufficient to provide to enterprises with the low latency and speed required to fully utilize their SSD storage. In light of this, NVMe with the latest drive interface was deployed, and it has become more essential for data centers. The performance of NVMe SSD outshines other devices, while the price per terabyte of storage is only slightly higher. Therefore, analyses such as IDC believe that NVMe will replace traditional storage protocols, especially for major workloads that are sensitive to latency. QCell SQFast, or NVMe flash storage, achieves the performance requirements of the enterprise high-performance computing infrastructures with high IOPS at a micro-level latency. It is designed for enterprise users, providing excellent storage performance, enterprise-grade reliability, and a flexible and easy-to-use management system. With Western Digital UltraStar, the third generation of NVMe SSD, with PCIe Gen 3.1, the capacities are up to 15 TB in a U.2 2.5-inch form factor. In QCell NVMe all-flash array, brings extraordinary performance and how fast it is. Let's see how we got from the result. The charts here reveal the performance number that under RAID 5 and RAID 6 configuration, the system respectively brings up to 608,000 and 616,000 IOPS on random read. And when it was under the extremely low latency of less than 0.5 milliseconds, it still reflects the outstanding performance of nearly 230,000 IOPS. On the other hand, for random write, both RAID 5 and RAID 6 achieved a latency under 0.3 millisecond with outstanding IOPS. It is worth highlighting that latency remains under 1 millisecond, while IOPS reaches more than 80,000 under both configurations. That is, the storage offers remarkable performance while parity bits are involved. The performance of RAID 10 configuration is listed here for further comparison. The results reveal that the overall performance isn't seriously affected because of the parity. Therefore, the integration of SQFast and Western Digital NVMe drive is capable of providing marvelous performance without sacrificing too much space. The speed of NVMe-based storage platforms meets the requirement of technologies such as edge computing, artificial intelligence, and virtualization. The traditional storage devices used to have bottlenecks like certain computing-intensive tasks, and the NVMe offers solutions to the issue. Thanks for your attention, and always feel free to contact us if you would like to know more about QCell solutions. We will be very happy to hear from you.